All right, guys, here is the 3.2 lesson. We're talking today about logarithmic functions. Yesterday we did exponential. Today we're going to do logarithmic. Tomorrow in class, I'll work with you guys on some examples. We'll go through some things maybe from WebAssign and some questions you may have to clarify, but just make sure you guys are taking good notes, following through with everything, and then anything you have questions on, let me know. When they talk about a definition of a log with the base b, okay, what they're saying here, when it says for every x greater than 0, they're telling you that the base of the log cannot be 0. So right here, the base of the log cannot be 0. And that it also cannot be negative, right? So it can't be 0 and it can't be negative. You can't take the 0 log of something and you can't take a negative log. Here, where they're telling you that the a term, it has to be greater. They're saying that your log will never be negative. Log will never, ever, we'll say never be negative. You can't take the log of a negative number. And your a term will never equal 1 because anything raised to the first power, or 1, I'm sorry, raised to any power will give you 1. Like 1 squared is 1. 1 to the 4th power is 1. 1 to the 297th power is 1. So that's what we have to pay attention to here. And then we're going to talk today about switching from log to exponential and exponential to log. You'll see it's super easy as we look through it and we convert back and forth. But you know that something is a logarithmic function because look, it has the word log in it. So we're going to be going back and forth from exponential to log, and you know something's a log function because it has the word log in it. So here's the example of a logarithmic form. If you notice, like I said, we have the word log in it. You have this little number that we're going to talk about all the time. That's your log base. Then you have your x and y. Then you look here at our exponential form. We have the same format. We have the y, the b, and the x. You just don't have the log. Instead of log, you have the exponent. That's why this is exponential form, and the log one is logarithmic. So we're going to go back and forth from converting from exponential to log and from log to exponential. And I'll show you how easy that is right now as we go through this, guys. First thing you do, it says write each equation in its equivalent exponential form. So first of all, we know that letter A, this says 4 equals log base 2 of x. You know this is in logarithmic form to begin with because it says log. So the way that we convert from log to exponential is your little log base number becomes the actual base. It becomes the big base. So you move that up, your log goes away, and then you switch the places of these two values. So your 4 becomes the exponent and your x becomes the answer here. And then if you were to evaluate this, 2 to the 4th power, x would be 16. So in B, if I have x equals log 3 of 9. All right, so what you do to go to exponential form and then to evaluate it, your little log becomes the big base. It goes up, it becomes the big base. Your log goes away, and then 9 switches place with the x. So x becomes your exponent, and this becomes 9. So now you can answer this question. You can say 3 to what power gives me 2? So in your mind, you're like, okay, 3 to what power gives me 2? It would be 3 squared equals 9, so x equals 2. Another way you could look at this is use that one-to-one property that we talked about yesterday. What's another way that I could rewrite 9? I could rewrite that as 3 squared equals 3 to the x, right? And now that our bases are the same, we cross them off, and I get x equals 2. Okay, so now we're going to go from exponential to logarithmic. Now on your test, it's not going to say convert from log to exponential or exponential to log. It's just going to say convert from one to the other. So you have to recognize what form you're starting in and what form you're going to. So if I look at letter A, I have b to the 4th power equals 16. Now some of you can do this in your head, but I would like you to actually convert, move stuff around, and then answer the question. Opposite of what we just did before, our base was the little log index. 4 was on one side, 16 was on the other. So what we do to convert the other way is your base becomes the little log number. So this becomes log of b. And then again, 16 and 4 switch spots. So this becomes log base 16 equals 4. If I look at b, I have 5 to the second power equals x. Well, I know you guys know that 5 to the second power equals 25. I understand that. But they're asking you to write this in logarithmic form. So my base becomes my little log number. So I write log base 5. And then x and 2 switch spots. So x comes on this side, 2 comes on this side. So I get log base 5 of x equals 2. Okay, so now we're going to evaluate without a calculator. So let's switch from one form to the other and then find out what our answer is. So if I have log base 4 of x, where x equals 64, the way that we would write this is we would say log base 4 of 64. Well, what does that equal? We're wondering what that equals. So I'm going to go from logarithmic to exponential. So this little 4 becomes my big base. Log goes away, and my question mark, or my x, switches spots, and 64 goes over here. So we're solving here. 4 to what power gives me 64? And my answer is 3. All right, same thing here. Again, yesterday I told you, when you see a fraction, we should think negative exponent. So I'm going to rewrite this and plug this in right here. So I have log base 36 of 1/6. What does that equal? So when I rewrite this, 36 becomes my big base. Log goes away. This becomes up. And then 1/6 and x switch spots. So 36 to what power gives me 1/6? Well, the square root of 36, right? If I had the square root of 36, that equals 6. Well, I can say that's the same thing as the square root. So I can rewrite square root as 1/2. So if I want it to be 1/6, then this would have to be a negative 1/2, because when I have 36 to the 1/2 power, in order for it to become a negative exponent, it would have to be on the bottom. So this would be x equals negative 1/2. Another way that we could look at this, if you guys like to look at our one-to-one properties like we did yesterday, is we can say 36 to the x power equals 1/6. Now I can rewrite 36 as 6 squared, right? So 6 to the 2x equals, and I can rewrite 1/6 as 6 to the negative first. If I bring this up top here, well, now that my bases are the same, I can cross them out, and I have 2x equals negative 1. And then if I divide both sides by 2, I get x equals negative 1/2. So either way is perfectly fine. Now we're going to talk a little bit more about conversions and all that stuff, but you guys are going to have opportunities and problems where you have to use your calculator. So here's a nice little cheat sheet, a nice little look at how to use a calculator. We're going to talk about change of base and all that sort of stuff over the next few days. So just keep this handy for you guys to reference. But if you have a question like this that says use your calculator to evaluate, you literally plug this in your calculator. There is a button on your calculator that says log. It is already set into log base 10. So you would just put in your calculator, hit -3, then hit the log button, and then you plug in 2.7 and hit enter, and it'll give you your answer. Now, these properties are super duper important, and they're super easy. But you guys need to understand how to convert from one thing to the next, from exponential to logs and logs to exponentials, and then you'll see why these properties are so easy to understand. But this says log base a of 1 equals 0. Now, we talked about yesterday, anything raised to the 0 power equals 1. So if I was going to take this log expression and rewrite it as an exponential, I'd bring my base of a up and my log would go away. So I'd have a big A, and then our 0 and our 1 would switch spots. So this would become a to the 0 equals 1. And anything to the 0 power equals 1. So if you ever have a question, like on WebAssign, you'll have these questions, and it'll say log base 17 of 1 equals 0. Or log base 22 of 1 equals 0. Or if it's log base, 4,374 of 1 equals 0. Your answer is the same thing every single time. When you have a problem like this, your answer is going to be in this fashion. If it's log base something of 1 equals 0, Log base anything of 1 is always going to be 0, just like anything raised to 0 power is 1. All right, now I look here and I have log base A of A equals 1 because A equals A, all right? I know that's like, what? But look at this, guys. If you had log base 2 of 2 equals 1. All right, think about what you would do here. If you were going to rewrite this exponentially, this little 2 would become your base, big 2. The log goes away. And then these two spots switch. So this would be 2 to the first power equals 2. Right? Does that make sense? So if you had like log base 18 of 18, what does that equal? You would tell me it's 1 because 18 would become your big base. The log goes away. And then you'd say 18 to what power gives me 18? And you would tell me the first power. So whenever you have log base something of the same number, it's going to be 1. If you had log base 6 of 1/6, what does that equal? Well, let's think about this for a second. If I rewrite this exponentially, my 6 becomes my big base. The log goes away. So something comes over here, and then this becomes 1/6. Well, guys, what would I have to have in order for, no, I'm sorry, not 1/6, this becomes 1. What would 6 have to be in order for it to be a whole number? This would have to be a negative, right? So this would actually be -1. So again, whenever we see fractions, we always remember it's going to be a negative exponent. Same thing here. This is the thing. If you notice, the log base and the big base are the same. If you had log base 3 of 3 to the 4th power, the log 3 and the big 3 erase, so x equals whatever that exponent is for. If you had log base 5 of 5 to the 100, your log base 5 cancels, your answer is 100. If you had log base 4 to the -3rd, log base 4 and 4 cancel, and your answer is just -3. And then the last little property here, and again, this will be easier as we go through some examples. If it says log base A of x equals log base A of y, if you notice, both of these logs are the same.
Did you have
Same with our one-to-one property. As soon as you see that the bases are the same, you can cross them off. Well, here, as soon as you notice that the logs are the same, you can cross them off. So if I had log base 6 of 12 equals log base 6 of x, you notice both log bases are the same. They cross out. So x equals 12. So let's do some examples to kind of bring that into light here. All right, we want to solve this equation. So when we start off in log, we automatically want to convert to exponential. So my 3 comes up here, my big 3, log goes away, and x and 81 switch spots. So my x is my exponent now, and I have 81. So now you say to yourself, all right, x to what power, 3 to what power gives me 81? If that doesn't jump in your mind, that's okay. We can use our one-to-one property. What's another way I can write 81? With a base of 3, I could say 3 to the x equals 3 to the 4th power. Do you guys see now that the bases are the same? So x equals 4. If you have an equation like this, log base 5 of 1 equals x. Well, right away, you guys should know that's 0. But if you don't see it, that's fine. Go to change it, convert it to exponential. So 5 becomes my big base. This comes up. And then 1 comes to this side, and x goes to this side. So x becomes my exponent, and I have 1. We talked about this yesterday. 5 to what power will give me 1? That would be x equals 0, because anything to the 0 power is 1. So again, let's look at these examples here. I have 3 as a base, and then log 3 is an exponent. Well, when you have a base and a log that are the same, they cancel out. Your answer here is 15. Coming over here, I have log base 2, and then 2 to the 3rd power. Well, these two cancels out because they're the same, and my answer is 3. Coming down here, I have log base 9 of 9. They cancel out. When anything cancels out, divides by itself, you're left over with 1. And over here, I have log base 3 of 1/3. Well, now you're like, oh, wait a second, I see a fraction, so I should think negative. I'm going to rewrite this as log base 3 of 3 to the -1. Because if I bring this 3 up here, my exponent of 1 becomes negative. So now I see, oh, log base 3 of 3, my answer is -1. All right, now we're going to talk about graphs of logs. So yesterday we did exponentials. We had exponential growth and decay. What you guys need to know about logs is logs and exponentials are inverses of each other. So algebraically, if you were given two functions and one was an exponential and one was a log, if you notice, the exponential, here is your input and output, your x and y values, and then here is the log of the inverse. All that happens is your domain and your range switch. Your y's become your x's and your x's become your y's. What happens is that these two functions, since they're inverses of each other, they reflect over the line y equals x. So instead of a vertical asymptote, instead of a horizontal asymptote that we had yesterday, today we're going to have a vertical asymptote. Instead of our domain being negative infinity to positive infinity, that's going to be our range. Instead of finding a y-intercept, we're going to find the x. So it's the exact same thing, just everything is flipped. So let's look at some stuff, okay? Again, over here, we're comparing the two. We have our log functions and our exponential functions. It's very important that you guys see the difference in the way that these look. Okay, very important that we notice that. But the domain of log functions, all right, to find the domain of a log function, to find the domain, you have to find the vertical asymptote. These two things go hand in hand. The domain and the vertical asymptote go hand in hand. To find the vertical asymptote, you set whatever's in the parenthesis equal to 0. Your range is always going to be negative infinity, positive infinity. It's exactly the opposite of what we did yesterday. And then to find the x-intercept instead of the y, you plug in 0. So we're going to find x-intercepts today instead of the y. Our transformations are the same as what we talked about yesterday. If you're going to vertically move a log function up or down, you're going to add or subtract at the end. If you're going to shift the log function left and right, it's going to be in parentheses with the x. If you're going to reflect it over the x-axis, you have a negative out in front. If it's going to go over the y, it's with the x inside the parenthesis. If you're vertically going to stretch or shrink, you're going to multiply by something out in front of your function. And if you're going to horizontally stretch or shrink, it's going to be with the x and the opposite of what you think. Same thing we talked about yesterday and all of the other time before. I'm going to let you guys graph this one on your own. We can just throw some numbers in and that sort of thing. But I want to move along to what transformations would look like. Just by looking at this function, your transformation would be a reflection over the x-axis. Reflect over x. And this is going to move right 1 unit. The reason why is because our transformations do not change from any of the other functions that we've talked about. Your transformations stay the same. They still occur in the same spot. It's just that the function itself is changing. So if you look at a question like this, and you'll have something like this on reviews and on your, tests and stuff. To find all of the information that they're asking, you can do all of that. First thing you're going to do is, let's talk about, we have domain, range. We're going to do vertical asymptotes here and x-intercept. Yesterday we did horizontal asymptote and y-intercept. So the first thing I know is my range for my log functions is always negative infinity to positive infinity. My domain and my vertical asymptote go hand in hand. The way that you find the vertical asymptote is you set your parenthesis equal to 0. So I have x minus 5 equals 0. So if I'm going to solve this, I'm going to add 5 to both sides. So I have a vertical asymptote at x equals 5. Very important, guys, that you write x equals 5. That's the line that we're going to get really, 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 really close to, but not touch. So my domain, since this is a positive log function, it's going to get really, really close to x equals 5 and then continue on till infinity. If it was a negative, if it was a reflection, it would go the other way. Now to find the x-intercept, we plug in 0 for y. So I'm going to say, okay, y equals log base 4 x minus 5, right? So I'm going to plug in 0 for y. So I'm going to say 0 equals log base 4 of x minus 5. Now think about this, guys. This is a log. In order to solve logs, it's really easy if we just put it into exponential form. So my little base 4 becomes my big base. My log goes away. And then what happens with 0 and x plus 5? They switch spots, right? So this becomes 4 to the 0 power equals x minus 5. Can we solve this? Absolutely. 4 to the 0 power is 1 equals x minus 5. I'm going to plus 5 to both sides, and I get an x-intercept at 6. So you would write your x-intercept at 0, 6. Now, if you're going to sketch this graph, this is super easy to do because I know that my x-intercept is right here at 6, and I know that my vertical asymptote is at x equals 5. And our log functions, if they're positive, it's just going to go right along that vertical asymptote through the intercept and then makes a nice little smooth curve that way. We will practice more of these. I promise. I have a really extensive review for your 3-1 to 3-4 test that I'll probably give you on Thursday so we can work on it together Friday. You guys can work on it over the weekend, and then we can answer questions and stuff on Monday. So if we look here, guys, now we're going to talk about natural logs. That's the ln. There's an ln button on your calculator. That is the inverse of the e to the x. Okay, we talked about that yesterday. Our 2.17, that number that's fixed in our calculator. The inverse of that is your ln. Same concepts apply for everything with our logarithmic functions. The domain of your natural log is everything greater than 0. You would evaluate on your calculator by just simply hitting 2, the ln button, and then here instead of x, they want us to put 12.5, round to whatever decimal place they tell you to. Very important that we know how to use our calculators, guys. Super duper important. Same concepts apply when we talk about our properties of natural logs. It's the same as the properties of logarithms themselves. I just told you that natural log and e are inverses of each other. So if you have something like letter A here where it says -5 ln e, well, ln and e are inverses of each other, so they cross out. What's my answer here? -5. I have in letter B, e to the ln 7. Well, what did I just tell you? E and ln are inverses of each other, so this crosses off, and your answer here is 7. My last slide got cut off, so I'm not sure why, so I'm just going to write it myself. But you have f of x, you guys have f of x equals the natural log of x minus 3. All right, well, our same thing applies for what we just talked about with our logarithmic functions. We're going to find the domain, the range, our vertical asymptote, and our x-intercept. We can do all of that. Remember, domain and vertical asymptote go hand in hand. Our range is always going to be -infinity to positive infinity. To find our vertical asymptote, we're going to set what's in the parenthesis equal to 0. So x minus 3 equals 0. Add 3 to both sides, add 3. You have a vertical asymptote at x equals 3. So your vertical asymptote is at x equals 3. That means our domain is going to be from 3 to infinity. And we're going to find our x-intercept. So we have y equals the natural log of x minus 3. I'm going to plug in 0 for my y, and then I'm going to say I have ln of x minus 3. Well, to go from ln to exponential, right, the inverses of each other would be ln and e. So I'm going to say e, these two switch spots, e to the 0 equals x minus 3. Well, guys, what's anything to the 0 power? I know that's a letter, but anything to the 0 power equals just 1. So now I add 3 to both sides, and I get my x-intercept is at 4, 0. So if I was going to graph this, 1, 2, 3, 4, I have an intercept right here at 4. My vertical asymptote is at 3. And then I just draw my natural log, which looks exactly like our logarithmic function. So there you guys go. Tomorrow, I will answer any questions you have. We're just going to wrap up 3-1 and 3-2. We're going to wrap up 3-1 and 3-2. So work on your web assign tonight, and tomorrow is going to be devoted to me answering questions for you guys. So please take really good notes. Okay, 1 second, honey. Take really good notes with Mr. Cabrera there. Ask questions as you need to. and I will see you guys tomorrow.